All right, grade 12, in the next series of short videos, we're going to go through very small concepts at a time to get to the end of higher level electricity. So I taught you guys already about AC currents. I taught you about transformers and how we can up the voltage or down the voltage. And we talked about power transmission in power lines and why we use transformers. But the last step is then converting that AC current that Nikola Tesla made for us, converting that AC current, which we use for transporting electricity, into DC current in our electronic devices. So your computer, every device needs to convert that AC into DC, and that requires a few steps. So over the next series of short videos, we're going to talk about how to do that step by step. So the first step that we're going to look at is the role of diodes. Diodes are an electrical component that we use to rectify or fix the direction of current, okay? Then after that, we want to smooth that current using devices called capacitors. These are the last two devices in the chapter, all right? And capacitors involve quite a few calculations, so we'll spend the last few videos learning how to do calculations with capacitors, okay? So thanks to Nikola Tesla, he gave us the ability to create a simple way of generating electricity, but that electricity is alternating current caused by the change of magnetic flux in a metal. So we get this plus minus type of current. Eventually what we want to do is we don't want variable current, and pulsating would mean that my devices are going to flicker. We want to turn this alternating current into a smooth, direct current, all right? Then my device is going to operate at a constant current and a constant power, and we can get the best out of our electronic devices. So our goal is to convert this into this over time. And on our way there, we're going to be making this, but we never want to make that, all right? So the first step to converting AC into DC is the process of current rectification. What you see here on the left is our typical AC graph. These are the peak currents. Remember, my root mean squared current would be my peak current divided by root 2, which would be there, okay? But my device does not want these negative currents. In fact, some electronic devices like your computer screen would damage if the current changed directions. So how do we take that input of AC and convert it into just positive current? Well, we use devices called diodes, which I have shown here on the bottom. When I put a diode into a circuit, and if I put it in the right way, I would be able to flip these negative currents so that they all become positive. So positive, and then all my currents are positive. So this that you see here is called a full wave rectified circuit, which in the end of this we're going to be able to make. All right, a full wave rectified circuit, never do I have a negative current, so the current is always flowing through my device, but it changes its value of current. It's going up like that. So diodes allow us to at least keep the current positive, but we still have this wavy type of current. Okay, we'll get there eventually. So what a diode is it's a type of material or device that only allows current to go through it in one direction. The symbol is this, it's in your data booklet. You got an arrow and a line. So the current always the positive flow has to go to the right. It never lets the current go in the other direction. So if I put a diode into a circuit, like I have over here, so if I put one diode into this circuit and my current here is AC, okay, for 1 second it'll be like that. The current is going to flow in that direction. But as soon as the AC current it flips signs, all right, so if I erase this, as soon as the current becomes positive on this side and negative on that side, the current tries to flow, but it can't. It gets blocked. It gets blocked on this side. It can't go through, all right? So only when the current is going in towards the right will it flow, okay? And that's what I see here. So this is the input signal, but only when the current is flowing to the right do I get DC voltage, okay? And I'll be missing that half. That would be the effect of putting one diode into a circuit. You would make that pattern. And on your IB practice test, you will see multiple choice questions that will put a diode into a circuit and say, pick which graph represents how the diode will perform in the circuit. This is the graph that would come out of that. We'd be missing the negative portions. But that's no good. My devices don't want to be missing current, and it's a waste of energy. So how do I make up for these lost currents? Well, what we end up doing is we make a sneaky combination of diodes. Okay, so let's say this is my device, and the device wants current to flow downwards. Okay, well, the way I connected these 4 diodes always makes sure that current will flow downwards through that, despite the fact that the AC current is changing. So in 1 second, if the AC current is looking that way, the current is going to flow. The diode makes it go up that way. It gets blocked down here. It gets blocked here. It goes down here. It gets blocked here, and it gets sent out that way. Okay, so that fulfilled what we want. We want the current to go down through that component. All right, but let's just get rid of these. Now what happens when the current switches? Okay, so if the current switches direction and we're left with positive negative, let's follow the flow of the current. It gets blocked down here, it flows up, gets blocked here, so then it flows down, it gets blocked here again, so it flows out, and then comes out the other side. So even when it flips, based on this sneaky combination of diodes, the current is always going down through the device. So this device would be like the screen in your computer. The screen would be attached in a diode combination, and that's called a Wheatstone bridge. A Wheatstone bridge. Your TOCOS textbook calls it a Wheatstone bridge, and you have to memorize how to draw that. Okay, and so what ends up happening is instead of having these empty spaces, now I will always have positive. Even though it's switched negative, the current will be going in one direction through my device, and I will get this pulsating effect. Okay, still though, my device will only operate with a voltage that is somewhere over here. So anytime the voltage sneaks down below, my device is going to turn off. So if you can imagine that your computer screen was connected to this, your computer screen would still flicker. It would turn on, turn off, turn on, turn off, turn on, turn off, turn on, turn off. We don't want that. Okay, so the next devices that we have to use allows us to trickle the current like that, so that every time that my AC current goes down, there's something else in the circuit that slowly releases charge to make sure that the current always, or the voltage always, stays above this threshold so that my device will stay on. And what allows us to do that are capacitors, and that's going to be the topic of the next few videos.